Bismillahirrahmanirrahim. In the last lecture, we studied the specifications and the promises and the evolution of 5G. That was more focused on how things got better and what are the numbers associated. That included the penetration rate, the number of SIM connections, the revenues, the contribution to the GDP, the traffic, how it got evolved with time, the effect of the IoT, the geographical area that contributed to the traffic growth, the driving factors for the data growth, and the mobile networks evolution, and that is from GSM up till IMT 2020 that the 5G has promised, and the end-to-end ecosystem of the 5G, the expectations from the 5G, and 5G mobile network expected performance. That included numbers and parameters associated with that. In today's lecture, we're going to look at more of the theory related to 5G. So the things obviously are very interesting with regards to what we have studied in the last lecture. But now we're going to, see the things in a bit of more detail. And let's see. So what is 5G? 5G is the fifth generation of mobile networks, a significant evolution of today's 4G LTE networks. 5G has been designed to meet the very large growth in data and connectivity of today's modern society, the Internet of Things with billions of connected devices and tomorrow's innovation. So that is sort of, a description of what 5G is all about. 5G will initially operate in conjunction with existing 4G networks before evolving a fully standalone network in subsequent releases and coverage expansion. So you can say that it's not that 5G will, when it will come into place, it will completely take over 4G right away. Rather, that would be a gradual approach. And initially, the existing 4G network will uh, work along with the 5G. But with time, the eventual target is to completely replace the existing 4G network. So that was not the case for, when the things got evolved from 2G to 2.5G to 2.75G to 3G, to different variants of the 3G and then to 4G. Because the existing network was very much, linked to the network that was coming in the offing. Whereas in case of 5G, the eventual target is to completely replace its the predecessors of that, right? But initially, as I said, that it will work in conjunction with the existing 4G network, but eventual target is that it would be a complete standalone network in the subsequent releases and the coverage expansion. So this is something that is different from the generations before the 5G. In addition to delivering fast connections and greater capacity, a very important advantage of 5G is the fast response time. We know that is latency. So latency is the time that the devices take to respond to each other over the wireless network. 3G network had a typical response time of 100 milliseconds. The 4G had a response time of around 30 milliseconds, whereas in case of 5G, it is as low as 1 millisecond. So you can see that it's a substantial rise in the technology, the substantial rise in the speed, and hence a much better latency as compared to 4G. You can say that from 3G to 4G, that is from 100 milliseconds to 30 milliseconds. So it's kind of like a factor of 3, right? Whereas in case of 5G, you can see that from 30 milliseconds, the jump is directly to 1 millisecond. So that is a factor of 30. So 5G is a substantial improvement in the already existing network. This is virtually instantaneous, opening up a new world of connected applications. So you can see in this figure that how the things have been shown that we have vehicles, smart farms, remotely things are getting managed, shopping centers, everything is kind of connected. Hospitals, smart businesses, stadiums, smart utilities. We are already, living in such kind of a society, but that would be much faster in case of 5G, and hence the speed is a significant factor. And when we say speed, we mean latency in terms of technical terminology. What will 5G enable? 5G will enable instantaneous connectivity to billions of devices. Yes, you read this correctly. It's not millions of devices, rather, this is billions of devices, the Internet of Things, and a truly connected world, right? So when we talk about Internet of Things, so the thing that will enable, the enabler of that is obviously 5G. I mean, it's of no use if the things are connected to each other, but the connectivity is not at par with regards to the speed, right? So 5G will ensure that the billions of devices are connected to each other, and in a way that is secure and also faster. Okay, 5G connecting the community. 5G will provide the speed, low latency connectivity to enable a new generation of application services and mobile opportunities that have not been seen before. There are three categories for use case for 5G. So this is very important. The first is the massive machine-to-machine communication. That is also called the Internet of Things. That involves connecting billions of devices without human intervention at a scale not seen before. This has the potential to revolutionize modern industrial processes and application, including agriculture, manufacturing, business communication. So you just name, the area, and the 5G would be targeting that. So the first category for use case for 5G is the machine-to-machine communication, and that is also massive, right? That is also called as Internet of Things. Yes. So billions of devices connected to each other without human intervention and at a very fast pace and also secure. Ultra reliable low latency communication. The mission critical, including real-time control of devices, industrial robotics, vehicle-to-vehicle communications, and safety systems, autonomous driving, and safer transport networks. Low latency communications also opens up a new world where remote medical care, procedures, and treatment are all possible. So the second use case for 5G is ultra reliable low latency communication. We just don't want a machine to machine communication. That should also be reliable, right? So ultra reliable and low latency. So although we expect a sort of a trade-off between the latency and the reliability, but in 5G, it has to ensure that it should be ultra reliable and it should have a low latency at the same time. The third use case is enhanced mobile broadband, providing significantly faster data speeds and greater capacity, keeping the world connected. New applications will include fixed wireless internet access for homes, outdoor broadcast applications without need for broadcast vans, and greater connectivity for people on the move. So obviously, these three things are also interrelated with each other, but seeing them, with a different lens, we should have a massive machine-to-machine communication, and that communication should be having a very low latency and should at the same time should have uh, good reliability. At the same time, the enhanced mobile broadband to the existing network, and hence it would promise a faster data speed and hence also the greater capacity. So more data would be handled in the 5G. For communities, 5G will enable connection of billions of devices for our smart cities, smart schools, smart homes, smart and safer vehicles, enhance healthcare and education, and provide a safer and more efficient place to live. That is what 5G will offer for the communities. For businesses and industry, 5G and IoT will provide a wealth of data, allowing them to gain insights into their operations like never seen before. Businesses will operate and make key decisions driven by data, innovating agriculture, smart farms, and manufacturing, paving the way for cost savings, better customer experience, and long-term growth. Whenever we talk about business, so obviously the money is central to that, right? So we don't want the rise or the betterment in the technology at a higher cost. We want to ensure that we get a better facility in terms of technology at a minimum possible cost. So 5G will try to ensure that, and hence, you know, the businesses and industry will also grow because of the 5G. Okay, the important thing, the new and emerging technologies such as virtual and augmented reality will be accessible by everyone. So this is something that was, a kind of a terminology that was not, available to masses. The virtual and the augmented reality, when we talk about the 4G um and the technology before that. So in this case, we will have the virtual and augmented reality, and that should be accessible by everyone, right? So virtual reality provides connected experiences that were not possible before. With 5G and VR, that is a virtual reality, you will be able to travel to your favorite city, watch a live football match with the feeling of being at the ground. For example, you are not physically sitting in the stadium, but you should be watching the match. And at the same time, you should be having a feeling that you are in the ground, or even be able to inspect real estate and walk through a new home, all from the comfort of your couch. For example, you're sitting on a sofa in your home, but you should be able to see, for example, some home at some other city, and you should be able to move along in different rooms and try to get a feeling of that. Obviously this thing was not something that was very common for everyone, right? 5G will keep us connected in tomorrow's smart cities, smart homes, smart schools, and enable opportunities that we have not even thought of yet. So this is something that is, something that should be seen as a significant improvement, or the significant difference, I think is a better terminology with regards to the technologies that were before 5G. You can see in this figure that we have connected farm. There is vehicle tracking, smart vehicle, equipment monitoring, machinery is being tracked, irrigation management, livestock tracking, access control. This is sort of a depiction of a connected farm. So all of the farm is connected to each other. It's not that the person, for example, sitting in this car and needs to, go physically go to this cow and see what exactly this cow is going through. So he should be able to, for example, all the health related data of that cow, the person sitting in this car should be able to monitor that, right? So this is a sort of a depiction of a connected farm. Okay. The next thing, when did 5G launch? Initial 5G services commenced in many countries in year 2019. And widespread availability of 5G is expected by year 2025. So this is important. So many people, ask that when 5G is getting launched, for example, in our country, uh, a lot of talk is been going on that 5G is getting launched in year 2024 or 2025. Yes, that's correct. But talking about, globally, many countries, the 5G is already launched, and it's in its initial stages, but the widespread availability globally is expected by 2025. It does not mean that all the countries will have 5G by 2025. It means that it should be widely spread among many countries. It's not even that it should be available in most of the countries, but in many countries is the right terminology with regards to if we talk about year 2025, yes. What are the first applications for 5G? Fixed wireless access for homes and enhanced mobile broadband services are the first applications. Obviously, the cellular phone users will, get the first feeling of that how 5G will change their lives. Tablets, wireless access modems, and hotspots. So these are the areas that would be targeted first. What do 5G devices offer? The prime benefit of a 5G devices will be significantly faster speeds in data access, downloading and streaming content. In addition, 5G devices will have increased computing power and make use of low latency, meaning that the devices will enjoy virtual instantaneous connections to the network, right? As well as greater connectivity when on the move due to the use of advanced antenna beam steering. So we will talk about this antenna beam steering in a little while, but at least by now you should be able to know that antenna beam steering has a significant role to play in this overall 5G and its evolution. What devices are available for 5G? Mobile handsets, tablets, and hotspots. It could be 3G, 4G, and 5G connectivity were launched in 2019, and low latency and widespread machine-to-machine applications using 5G will be developed in the coming years. So obviously, the hardware associated with 5G, needs to get upgraded, and the things are being done starting from year 2019. How does 5G work? Most operators will initially integrate 5G network with existing 4G networks to provide a continuous connection, right? So it's not that the experimentation would be done by completely putting off 4G network and bringing in the 5G. Rather, the existing 4G network would be upgraded in a way that both of them can simultaneously be used by the users. And as I said earlier, that with time, the 5G will be like a standalone system, and hence it would be completely, you know, dismantled from the existing 4G system. 5G network architecture, very important subject, that what exactly would be the 5G network architecture, right? Okay, the 5G network architecture illustrating 5G and 4G working together with central and local servers providing faster content to users and low latency application. You can see over here that we have a 5G network architecture. We have a local servers, right? At the same time, we have 5G small cell. We have a 4G macro cell. This is a 4G macro cell. This is a 5G macro cell. This is a 4G macro cell, 5G small cell. So you can see that it is the overall system is integrated in a way that we have 4G and 5G systems connected to each other, right? A mobile network has two main components. We already know that it has a radio access network and the core network. Let me give you a quick recap of radio access network, just for those of you who are not familiar with the radio access network. The radio access network connects individual devices like mobile phones, computers to the core network. It consists of various radio transmitters, receivers, and antennas to facilitate wireless communication. RAN is responsible for managing the radio communications with the mobile devices, including modulation, demodulation, error handling, mobile management, etc. The components that are included in RAN are the base stations, the node Bs, the E node Bs for the advanced 5G, 4G networks. These are typical units that provide radio coverage to devices. Their names vary with the technology used. It depends, for example, 2G, 3G, 4G, 5G. The antennas transmit and radio signals. Obviously, the base stations and antennas both come under this RAN. The base station controller, uh, the network controller, they manage resources and handovers in some RAN architectures. RANs differ based on the technology, can be macrocell, microcell, picocell, femtocell, depending on the coverage area. So it all depends on the coverage area. If the coverage area is very small, obviously the cell would be small. Cell is the area where the users get an access to the network, right? Okay, so that was a recap of RAN. And now talking about the radio access network that consists of various types of facilities, including small cells, tower, mats, dedicated in-building and home system that connect mobile users and wireless devices to the main core network. The small cells will be a major feature of 5G. So I have used this terminology before when we were looking at this figure. Small cells is something that is a major feature of this 5G network, particularly at the new millimeter wave frequencies where the connection range is very short. So let me tell you what millimeter wave is all about. Okay, the term millimeter wave refers to a specific part of the radio frequency spectrum between that is 24 gigahertz and 100 gigahertz, which have, this is a very huge frequency. So it should have a very low wavelength. This section of the spectrum is pretty much unused. So millimeter wave technology aims to greatly increase the amount of bandwidth available. So as the frequency is more, the bandwidth definitely would be more, and at the same time this part of the spectrum is pretty much unused, so that was more suitable for this new kind of technology that the 5G promises. To provide a continuous connection, small cells will be distributed in clusters depending on where users require connection, which will complement the macro network that provides a wide area, right? So macro cell would be covering a larger area, where the small cell would be covering a smaller area and at a very high frequency. This is important. 5G macro cells will use MIMO, that is multiple input, multiple output antennas that have multiple elements or connections to send and receive more data simultaneously. The benefit to user is that more people can simultaneously connect to the network and maintain high throughput. So in MIMO, we have multiple input, multiple output. That is, we don't have a single antenna for, one base station. It will have multiple antennas uh, for on the input side and multiple antennas on the output side. That is, multiple antennas would be they would be used in order to transmit something, and multiple antennas would be used in order to acquire the signal at the receiver, right? MIMO antennas are a very large number of antenna elements that are also referred to as massive MIMO. However, physical size is similar to existing 3G and 4G base stations. So when we say large number of antennas, it does not mean that it would be covering a larger area, where the area would be more or less like it was in 4G and the technologies before that. So the core network. Okay, just a quick recap of the core network. The core network is the central part of the telecommunication network that manages data and voice traffic and provides connectivity to various network services. It handles high-level functions such as authentication, voice call control, data routing, charging, and service provision. It includes a component that includes mobile switching center, MSC, that we have already discussed in our lectures when we were studying evolution from 1G to 4G, and also we studied mobile switching centers in detail when we were discussing the topic on 2G. The packet gateway, these handle voice data switching, manage network connections. We know what home location register is all about. Databases that store information about network subscribers. The authentication center that was responsible for authenticating users and devices. With each generation of mobile network, the core network has evolved to support increased data rates, low latency, and new services like IoT and machine-to-machine communication. So things have gone better with regards to the core network as we moved along in the technology. The core network is a mobile exchange and data network that manages all of the mobile voice data and internet connections. For 5G, the core network is being redesigned to better integrate with the internet and cloud-based services, and also includes distributed servers across the network, improving the response times. Okay, let me tell you about the cloud service. I think most of you must be knowing what the cloud service is all about. A cloud service is a logical server that is built, hosted, and delivered through a cloud computing platform over the internet. Cloud servers possess and exhibit similar capabilities and functionalities to a typical server, but are accessed remotely from a cloud service provider. If you have a huge data and you want that to be accessed from everywhere, you can put your data on the cloud server and make use of that. Uh, Many of the advanced features of 5G, including network function visualization and network slicing for different application services, will be managed in the core. So we'll be talking about this network slicing and network function visualization, because this is something that is significantly different from the system before that. The following illustration shows example of local cloud server that I have just talked about, providing faster content to users and low latency applications for vehicle collision avoidance system. You can see that there are cars on the highway, and we have sort of a 5G macro system. The both cars are connected to this 5G macro server, and they are also connected to a local user. And say a 5G small cell is also nearby, right? So in the 5G network architecture, multiple cars, are connected to this 5G macro server. So vehicle collision avoidance system uh, is something that is a very hot topic of research these days with regards to 5G. Okay, Ji, talking about the network slicing, uh, it enables a smart way to segment the network for a particular industry, business, or application. This is very interesting. For example, emergency services could operate on a network slice independently from the other users. So you know what the slicing means. For example, to separate a chunk out of the existing network, that is a separate slice, and giving all the resources or the dedicated resources to that particular service. That is the meaning of the network slice. So here we have given the example that the emergency services could operate on a network slice that would be independent from the other, because it is something, an application that is a high priority application. So network slicing could be done for that particular application or the service, right? So this is something that is a feature that is dedicated for a particular application, and this feature is obviously a new addition to the existing network, and then obviously 5G is what promises this network slicing. Network function virtualization, it is the ability of the system of the network functions in a real time at any desired location within the operator's cloud platform. Network functions that used to run on a dedicated hardware, for example, a firewall and encryption at business premises, can now operate on a software on a virtual machine. Network function virtualization is crucial to enable the high speed and agility to support new business application, and an important technology for a 5G ready core. Again, this is something that is, more focused for the 5G, and this is something that is, people are not aware or familiar with network function visualization. Here, the network functions in the real time at any desired location uh, in and within the operator's cloud platform. The network functions that were used to run on a dedicated hardware now instead will run on the software, right? So for example, we need a separate hardware for some functionalities and another hardware for another functionality and another hardware for another functionality, right? So, this is the hardware one that is performing some function. Now, this is the hardware two performing some other function. This is the hardware three that is performing some other function. So this hardware two is dependent upon the output from the hardware one. And this hardware three is dependent upon the input or the output from the hardware two that is fed as an input to this hardware three. So instead of having this, we should in some way try to emulate what all these three hardware blocks are doing and do all of that work instead in a software, right? So that would be much more faster, and hence, far greater speed, can be expected with regards to such kind of uh, technology, right? So this is what the network function visualization is all about, right? So okay, 5G integration with the 4G. When 5G connection is established, the user equipment or device will connect to both the 4G network to provide the controlling signaling and to the 5G network to help provide the fast data connection by adding to the existing 4G capacity, that is. When there is a limited 5G coverage, the data is carried on to the 4G network, providing the continuous connection. Essentially, within this design, the 5G network is complementing the existing 4G network. And this is something that we should not be, too much surprised with this, because this is what happens with, 4G and the system before that. We know that if we go to some place where we don't have a proper coverage of the 4G, we are automatically connected to the 3G. And for example, if we don't have a good coverage for the 3G, in that case, we are getting, the signal of E or Edge, that is the advanced version of 2G, that is a 2.75G. So similar is the case with the 5G. So 5G would be, 5G and 4G network would go in tandem with each other in the same way. How does 5G deliver continuous connection, greater capacity, faster speed, response times? The better connection is always connected. The 5G networks are designed to work in conjunction with the 4G networks using a range of macro cells, small cells, and dedicated in-building systems. Small cells are mini base stations designed for very localized coverage, typically from 10 meters to few hundred meters, providing in fill for a large macro network. Small cells are essential for the 5G networks as the millimeter wave frequencies have a very short connection range. We have just talked about that. The very high frequencies are more targeted in the 5G. So when we have a very high frequency, in that case, we have a shorter range. And when we have a shorter range, obviously, we would be needing a smaller cells, right? So, having a cell, right? So its coverage area would be lesser, right? Because it is operating on a very high frequency, and hence the coverage area is also lesser. So in case of macro cells or the BTSs, obviously they are covering huge areas and talking about in kilometers, right? So that is not the case for in case of the small mini cells in case of 5G. Increased spectrum, greater capacity, more users and faster speed. In many countries, the initial frequency bands for 5G are below 6 Hz in many cases, in the 3.3 to 3.8 gigahertz band, and similar frequencies to existing mobile and Wi-Fi networks. Additional mobile spectrum above 6 gigahertz, including the 26 to 28 gigahertz, often referred to as millimeter wave, will provide significantly more capacity compared to the current mobile technologies. The additional spectrum and greater capacity will enable more users, more data, and faster connections. It is also expected that there will be future reuse of existing low-band spectrum for 5G as legacy networks decline in usage and to support future use cases. This is a very important paragraph where we are trying to depict that in case of a very high frequency uh, that is promised for the 5G, the existing or the starting, sorry, initial frequency is around 6 gigahertz, right? And gradually they are moving toward the faster or the higher frequencies. But again, this also depends upon the application. For example, in the vehicular communication, the very high frequency bands in tens of gigahertz, in 70s, around 75 gigahertz for vehicular communication is also being used. And here we have also mentioned that it is expected that the future reuse of existing low band spectrum is also expected because legacy networks, decline in the usage. For example, the old system of frequencies that were used, like 5, 6 decades ago, that is not being used for many applications. So that can be used because we are already facing the spectrum scarcity, right? So the legacy networks in that case, they're sort of getting vacant. So that can be used for the 5G. And therefore, you can say that the frequencies, the frequencies that were in the low band can also be used in the 5G. So we cannot confine ourselves to, a very high millimeter wave frequencies. Very important thing, that is the massive MIMO. That is the multiple element base station, greater capacity, multiple user, faster rate. So first of all, let us see the 5G will use massive MIMO antenna that have very large number of antenna elements or connections to send and receive more data simultaneously. Okay. The benefit to user is that more people can simultaneously connect to the network and maintain a high throughput. For example, you're looking at a 4G sector antenna over here. On your right, we have a 5G massive MIMO. Whenever we use this term massive MIMO instead of a simple MIMO, we usually means the elements that are in tens, tens of elements, or as a rule of thumb, we say greater than 100 elements, for example, right? It can be, in thousands of elements as well, right? So typically, as a rule of thumb, we will see the more details regarding the massive MIMO, inshallah, in some other lecture. So as I said, as a rule of thumb, greater than 100 elements typically means massive MIMO, right? The overall physical size of the 5G massive MIMO antennas will be similar to 4G. It's not that it's a very big. So the number of elements, the small antennas that are connected over here, uh, are in a way that the overall size remains the same as that of the 4G. 5G user equipment include mobile phones and devices will also have MIMO antenna technology built in to the device for the millimeter wave frequencies. So obviously a significant hardware upgradation would be required in order for the hardware that would be using such kind of a system uh, in order to use this massive MIMO. Okay, so what is the need of this sort of massive MIMO? Because we need MIMO beamforming. So a number of antennas, when they are connected, they try to make a beam in the certain direction. Now it depends on what kind of a beam is being formed, because we need to go through a bit of literature related to antennas in that case. But a multiple antennas, they try to make a beam in a certain direction, right? So for example, this is a linear array of elements. We have 3, 4, 5, 6, 7, 8, 9, 10, 10 elements over here. So we have 10 TR modules, that is transmitter receive modules over here. They are used in a way that they try to make a beam in a certain direction. Obviously, it would have side lobes over here and the back lobe, right? But it will try to make a beam in a certain direction, and that beam would be controlled electronically. It's not that a mechanical physically you need to move all those elements and try to steer the beam in a certain direction. All you need to do is to electronically manipulate these antenna elements so that beam can be steered in any desired direction. And this is the beauty of MIMO beamforming, because you can steer the beam in any desired direction, and at the same time very quickly, because that is all being done electronically, right? Okay. Few more things. 4G LTE systems had a response time of around 20 to 30 milliseconds. 5G enhanced mobile broadband I will have 4 to 5 milliseconds, and 5G ultra reliable low latency communication. That would be upgradation of the starting version of the 5G will have latency of 1 millisecond. 5G network, mobile network architecture. We have already talked about that, but the details related to that. The core network changes with the redesigned core network signaling and distributed servers. The key feature is to move the content closer to the end user and to shorten the path between the devices for critical applications. Good examples are video on demand services, what is possible to store a copy or cache of the popular content in local servers so the time to access is quicker. So in the core network, that includes the base transceiver stations, the user equipment and related things. So what 5G is trying to do is it's trying all of those accessories related to the core network that are closer to the user. Since the frequency is high and hence we have mini cells that have a shorter range. So more the core is getting closer to the end user, right? And by having such kind of overall system, it's trying to uh, have a quicker access time. Obviously, there are a number of factors that are related to that that we have also discussed before. In case of the radio network access changes to access the low latency, the RAN will need to be reconfigured in a manner that is highly flexible and software configurable to support the very large different characteristics of the different devices that the 5G system envisages. Low latency and the high reliability over the air interface requires new radio technologies to minimize the time delays through the radio within a few time transmit intervals along with robustness and coding improvements to achieve high degree of reliability. For example, one message is delayed or lost in every billion, right? Implementing a virtual dynamic and configurable RAN allows the network to perform at very low latency and high throughput, but it also allows mobile network to adjust to changes in network traffic, network faults, and new topology requirements. What will be reconfigured? The new architecture will exist as 4G, 5G split RAN, because obviously we don't want a sudden change or you know, uh, advancement into the 5G standalone system. Rather, we need sort of an integrated system, as we just talked about a little while ago, where the user plane 5G and the control plane 4G are separate. This requires the separation of the general purpose hardware and specialized network hardware. The functionality of the general purpose hardware are suitable for network function visualization. For example, that we talked about, that we need to have software configurability in order to, try to emulate the thing that the hardware performs, and try to have, sort of a dedicated hardware that tries to mimic the output of, a physical hardware, where the specialized hardware in the LAN will become dynamically configurable. How to configure that? Obviously, the software will be configuring that particular specialized hardware. So let me just repeat this thing. Instead of a dedicated hardware for a particular thing, we have a specialized hardware, right, that is dynamically configured for any type of task that we may like to perform. So that is it. These were the sort of details regarding the 5G and the architecture associated with the 5G. So obviously that would complement what we studied in the last lecture related to how 5G got evolved into the market, and what it exactly promises. So I will end here. Thank you.